Welcome back. Let's review our simplifying radical expressions from yesterday's lesson and what we went over in class today. So let's say we start with something. I'll start with a smaller number, something like the square root of 18. And remember, you split that into a perfect square. You look for factors of 18. We know that 9 and 2, 6 and 3 are factors of 18, and of course 1 and 18. This one isn't going to get us anywhere because it won't change this number. This one won't get us anywhere because there's no perfect square. However, with this one, 9 being a perfect square, we can split this into 9 times 2. We rewrite it to be the square root of 9 times the square root of 2, which would then become 3 times the square root of 2. So this is completely simplified version of our square root of 18. Now if I went, let's say, a little bit further and I had something like the square root of 72. And let's say I don't find the highest perfect square, I just find a perfect square that goes into it. For instance, I could break this into 4 times 18. 4 is a perfect square, 18 is not. So square root of 4 times the square root of 18. And we get 2 times the square root of 18. We know from this previous example over here on the left that 18 has a perfect square that goes into it as well. So square root of 9 times the square root of 2. Remember that once you do this, everything here is multiplication, so this becomes 2 times the square root of 9, which is 3, times the square root of 2. So you end up with 6 times the square root of 2. And there you go. Voila! Okay, so now we're going to start, actually we're staying in section 2, but we're doing a couple more things with it. We're going to do square roots with variables, and first we're going to start with estimating square roots. So if we want to estimate, for example, that square root of 18 that we had from the previous example, since it's not exactly a perfect square, we don't know exactly what the decimal is, but we can try and figure out at least kind of where it lies. So the first thing that you want to find is the closest perfect square above and below your number. So let's say we have this problem, square root of 18. What are our closest perfect squares, both above and below? Well, below 18 would be 16, would be a perfect square below. And above it, our next one above it would be 25. Okay, so we want to take the square root of those numbers. This is our second step. So once we do the square root of those numbers, we get 4 is the square root of 16. Okay, and then we have 5 is the square root of 25. We write it in inequality form, smallest number on the left over here. The square root problem given to you, this one right here, to square root of 18, that's going to go in the middle. And then we are going to use our inequality sign, and it will always be pointing to the left like this. So what this is saying is that the square root of 18 is smaller than 5, but it is bigger than 4. So that's how you would estimate. And since 18, if you look at these three numbers in a row, since 18 is closer to 16, the square root of 18 will be more like 4.1, 4.2, somewhere around there. If it was closer to 25, then it would be 4.8, 4.9, something closer. So a second example, let's say we have something like the square root of 82. Okay, well, we know that, oh no, it's frozen. Dang it. We know that 82 is not a perfect square. So we're going to find the closest perfect squares above and below. Well, we know that 81 is a perfect square, and that falls below the number 82. And we know that 100 is a perfect square, and that falls directly above the number 82. So the square root of 81 is 9. We put our original problem in the middle, so we take our square root of 82. The square root of 100 is 10, and then put our inequality signs pointing to the left. So this means this number would fall somewhere between the numbers 9 and 10, some decimal in between. That's not so bad, right? Of course not. Okay, so before we get into taking square roots with variables, I want you to kind of remember back when we were dealing with variables that had the same base. Remember, we added the exponents. So x squared times x to the third would be x, and then our exponent becomes 2 plus 3, which is x to the fifth. Well, if you think about what it means to square a value, whether it's a number or an expression, whatever, it means to multiply the expression by itself. So here are some examples. X times x, we are squaring this because we're multiplying it by itself. Add the exponents, we get x squared. X squared times x squared, we're squaring it because we're multiplying it by itself. Add the exponents and you get x to the fourth. And there are a couple examples here because I want you to look at this number in particular, this exponent. And what do you notice every single time? Well, one thing you may notice is that they're going up by 2's, but another is that they are all even. So even when our original exponents were odd, when we added them, when we squared it, it became an even number. And this is really, really important. The reason that this is important is because variables with even exponents are perfect squares, always, always, always. So you write its square root outside of the radicals. So, as an example, if I had the square root of x to the 12th, well, since we have to add exponents together to get x to the 12th, this would mean it was x to the 6th times x to the 6th, right? So that means the square root is x to the 6th. Pretty simple. And the same thing would apply if I had x to the 14th and I want to do the square root. Well, what times itself would give you 14? It would be x to the 7th. Because if you multiplied those, you would get x to the 14th. So this would be your answer, x to the 7th. Any variables that have odd exponents are not perfect squares. So you rewrite it as the product of two terms. One of the terms' exponent will be 1 less than the original, and the other has an exponent of 1. So let me give you an easy example. Let's say I had x to the 5th, okay, and I wanted to do the square root. Well, there is nothing that we can multiply by itself to get x to the 5th. However, I could knock this down 1 to become x to the 4th times x, and we know that if there isn't an exponent written, it's a 1. Now this is an even exponent, and we know from up here even exponents are perfect squares. So the square root of x to the 4th, this would be x squared times x squared. So that means our x squared, we bring outside the radical, and we leave our other x underneath the radical. Okay, so we'll do a couple of these together to make sure you kind of got this. So, simplifying the square root. If I wanted the square root of x squared, we know that x squared means x times x, so your answer is x. Now, x to the 7th, split it up. 1 less, so x to the 6th times x, so this is still under the square root. X to the 6th means x to the 3rd times x to the 3rd. So we bring x to the 3rd out and leave our x underneath. Now when you look at this one, we have 3 different variables here. And it seems like it may be confusing, but you just take it one step at a time. Alright, so let's first look at our x values. So we have x to the 5th. Alright, so we're going to take that down to x to the 4th times x. And this would then become x squared times the square root of x. Now if I take the square root of y squared, this is an even exponent, so that means it's a perfect square. It's just y. And then we have the square root of z. Remember, if no exponent is written, it's a 1. 1's an odd number, so there is no simplified version of this. So look back now at everything that's on the outside of the square root. X squared is on the outside, and y is also on the outside. So in our final answer, x squared times y will be on the outside of the square root. And then when you look back at what's still underneath the square root, those are these two values. So then we would put our square root and put what's left underneath it. And x was underneath, and so was z. So there's your simplified version of that answer. All right, so square roots and numbers and variables. Oh my! Wizard of Oz, anyone? Take it one step at a time. We're going to simplify the number first and then deal with the variables. All right, square root of 18, we did this earlier, so I'm throwing that square root in there. This computer doesn't make those symbols, so I have to do it myself. We have done the square root of 18, so let's do this one at a time. Okay, so square root of 18 becomes the square root of 9 times the square root of 2, which then becomes 3 times the square root of 2. Simplified, we're done. Now we have x to the third. So x to the third, and we're doing the square root of that as well. Now it's odd, so we split it into one less, so x squared times x, and we're doing the square root of each of those. X squared, the square root of that is x, and then we have this. So now look at your numbers that are on the outside of the radical. 3 is on the outside and x is on the outside, so those remain on the outside. Underneath the square root you have 2 and x, so 2x stays underneath the square root there. All right, now with this one, I think instead of walking you through it, I will give you the answer and see if you are able to get through it on your own. Okay, so let's see here. We would have 3, we would have y to the third, z, and then under the square root we would have 3x, z. This is your totally simplified version. And let's see if you can get to this answer by simplifying this without me showing you how. I might even give you some extra credit for that if you can figure it out and show me the work. I'll think about it. Alright, now our last little bit, cubed roots. So what number or variable, when multiplied by itself 3 times, gives you the original number? And actually, did I get rid of? I did. Alright, so when we're doing the cubed roots, one thing that's really important, this right here is the square root symbol. Okay, so square root. This one, with a little 3 right here, means cubed root. Okay, so one thing I had said to you before is that there's little invisible 2 right here, kind of just like when we write x, we don't write a 1, but we know that there's a 1 exponent, a 1 coefficient. This is the same concept. Square root is kind of the basic symbol, and so we don't write the 2, it's just known that it's there. However, with cubed root, you do write this 3. So if I wanted to take the cubed root of x to the 27th, I would want to know what variable, x to what power, would give me 27 when I multiplied them. Well, in this case, if we take x to the third and multiply it by x to the third, no, that's not true. I'm sorry. Ignore that. I wasn't supposed to make this x to the 27th. I was supposed to make this x to the 9th. Sorry. Okay, anyway, so when we're doing the cubed root, we know that x to the third times x to the third times x to the third. If you add those all together, that gives you x to the 9th. So that leaves you with the cubed root being x to the third. Okay. I'm going to ask you to just ignore this one. I think I did the same thing on all of these. I totally screwed them up. Ignore that. But when you're doing the cubed roots of numbers, I'll just show you how to do that as well. So ignore this problem. Make this your new number 2. Cubed root means what number multiplied by itself 3 times, and in this case 4 times 4 would give you 16, and 16 times 4 would give you 64. So the cubed root of 64 is in fact 4. So there we go. And this song here is by request, and I totally forgot to put a dancing picture in here. Oh no, I'm sorry. But dance anyway.